show that. How far did we get into it? Do you remember? Let's just start right around there. Oh.
Can we turn the light
Temperatures
off?
over a longer time frame, these scientists found a persistent warming trend over the past 3 decades, with the average global temperature increasing by roughly 1/3 of a degree Fahrenheit per decade. This past decade, from 2000 to 2009, was the warmest yet. And when looking back all the way to 1880, the year when precise temperature record-keeping began, scientists observed about a 1.5 degree Fahrenheit rise in global temperature.
There are already beginning to be effects of 1 or 2 degrees warming, and if we get 5 or 10 degrees warming several decades downstream, there will be huge effects.
GISS scientists came to these results after analyzing information from 3 sources: data from more than 1,000 weather stations around the globe, satellite observations of sea surface temperature, and measurements from Antarctic research stations. So what's the cause of this long-term warming trend? While there are several natural processes that can cause subtle climate warming or cooling, like variations in solar activity, fluctuations in ocean currents, and volcanic eruptions, climate scientists believe that the rising levels of carbon dioxide and other greenhouse gases are the dominant factor driving the rise.
If we want to limit climate change and keep it under an additional 1 degree Celsius or 2 degrees Fahrenheit, we would need to begin to decrease the CO2 emissions gradually so that by the end of the century, CO2 stopped increasing.
So while 2009's temperature may not have been the global record breaker, it is in line with the long-term trend, telling scientists that the planet is getting warmer.
Those NASA websites are real cool. You can get a hold of all their data and look at it yourself from the satellites they're putting up. One other one I wanted to show. It's only 3 minutes.
For 2.5 million years, the Earth's climate has fluctuated, cycling from ice ages to warmer periods. But in the last century, the planet's temperature has risen unusually fast, about 1.2 to 1.4 degrees Fahrenheit. Scientists believe it's human activity that's driving the temperatures up, a process known as global warming. Ever since the Industrial Revolution began, factories, power plants, and eventually cars have burned fossil fuels such as oil and coal, releasing huge amounts of carbon dioxide and other gases into the atmosphere. These greenhouse gases trap heat near the Earth through a naturally occurring process called the greenhouse effect. The greenhouse effect begins with the sun and the energy it radiates to the Earth. The Earth and the atmosphere absorb some of this energy, while the rest is radiated back into space. Naturally occurring gases in the atmosphere trap some of this energy and reflect it back, warming the Earth. Scientists now believe that the greenhouse effect is being intensified by the extra greenhouse gases that humans have released. Evidence for global warming includes a recent string of very warm years. Scientists report that 1998 was the warmest year in measured history, with 2005 coming in second. Meanwhile, readings taken from ice cores show that the greenhouse gases carbon dioxide and methane have hit their highest levels in the past 420,000 years. Arctic sea ice is also shrinking. According to NASA studies, the extent of Arctic sea ice has declined about 10% in the last 30 years. As long as industrialized nations consume energy and developing countries increase their fossil fuel consumption, the concentration of greenhouse gases in the atmosphere will continue to rise. Researchers predict that temperatures will increase about 2 to 10 degrees Fahrenheit by the end of the century. What's less certain is what rising temperatures mean for the planet. Some climate models predict subtle changes. Others forecast rising sea levels which could flood coastal areas around the world. Weather patterns could change, making hurricanes more frequent. Severe droughts could become more common in areas, and species unable to adapt to the changing conditions would face extinction. Although much remains to be learned about global warming, many organizations advocate cutting greenhouse gas emissions to reduce the impact of global warming. Consumers can help by saving energy around the house, switching to compact fluorescent light bulbs, and driving fewer miles in the car each week. These simple changes may help keep the Earth cooler in the future.
Huh. Okay, so global warming is a problem. And one of the things that global warming does is it melts the Arctic sea ice. So we're interested in this being marine biologists. Did you know that the North Pole of the Earth is covered with ice? That's where Santa Claus lives. It's big, y'all. We're going to kill Santa Claus here. And the elves and all that. Melting of Arctic sea ice has intensified. In the summer months, there's been less and less Arctic ice. In just a couple of decades, it is expected to be completely gone in the summer. I'll show you some video of the Arctic sea ice because they've been photographing this for many years with satellites, and you can see how the amount of it is getting smaller and smaller. The lack of Arctic ice causes sun that used to bounce off the ice to be absorbed by the ocean, speeding up the warming process. So this is the Earth. And this is the sun. And a happy sun? And in the North Pole of the Earth, you have all this Arctic ice that comes about every winter. This is ice. And as you increase the amount of gases in the atmosphere, of greenhouse gases, the planet gets hotter, and the ice starts to melt. And so this amount of ice gets smaller, you see. I'll draw little dotted lines. Over the years, it gets smaller and smaller. Every summer, it melts. It's just frozen water floating on the ocean. And the thing about ice is, what color is ice? It's white. And white reflects light. So when the sunlight hits it, it bounces off the ice. But if the ice is gone, then you have water, and the water is a lot darker color. And the water will absorb the sunlight. So instead of bouncing off, the water absorbs the sunlight. So when the ice is gone, the water gets warmer. So we have two things going on in the polar regions. We have the greenhouse gases building up all over the globe, heating up. And then when the ice melts, more sunlight is absorbed by the water. So it heats up even faster. We call this a positive feedback loop. The hotter it gets, the more the ice melts, and that makes it get even hotter. And so it keeps driving it up in a single direction. So scientists estimate that the temperature change is not going to happen on the globe evenly. They estimate that that in maybe 50 years or maybe 100 years, it's hard to tell, that the equator, temperatures at the equator might go up 2 degrees, but temperatures at the poles might go up 10 degrees because of this melting ice phenomenon. So you're going to get a lot hotter at the poles of the Earth. Of course, it has a bad effect on organisms that live there. The polar bears are dependent on the ice. Guess what? As the amount of ice goes down, the number of polar bears go down. They don't have anywhere to live, you see. Here's it shows, the yellow outline there is where the ice, Arctic sea ice, was between 1979 and 2000. It covered and went out to about the yellow line. This is a picture of the North Pole. That dot right there is the North Pole. We're looking down on the globe. See? And so between 1979 and 2000, it was out here. In 2005, it got all the way out down here. In 2007, it got all the way here. They expect that in about 20 years, it will be completely gone in the summer. There will be no more ice at the North Pole in the summer. And that's a big deal. A lot of people like it, especially people who do trade, because you can take a ship now from North America and sail right across to Russia here and deliver your goods. So those people like it a lot. But it's bad as far as the warming of the planet is concerned. All this ice is not reflecting sunlight anymore. So it'll really speed up the warming of the planet. That's a huge area. And the dark water will absorb the sunlight. So we're going to get hot real fast because that's going to be gone. Here's video footage of it. So it doesn't have any audio. But these are readings taken from the NASA satellites. And that's it. That's how it's changed over the years. Now, every winter it gets larger, but every summer it melts to that point. And so they've compiled that. They're just showing you the minimum amount of sea ice. Isn't that interesting? I got another view of the same thing. Whoops. Come on. So the black outline is where it usually hold on, let's follow this. So if you look at this black outline, why did it do that? Okay. Damn. Hard to do. Okay, so this black outline is the historical average minimum of ice. Normally it covers this black area. Here's where it was in 2012. So this is the most recent data here. That's all that's left. And so in every winter, that'll come back. So when the winter comes back, the ocean will freeze again up here, and the ice will come back. But in the summer, it gets smaller and smaller. So we're looking at the minimum amount. So that's a difference in a short amount of time, in just 20 years or so. We've basically lost all the Arctic sea ice. And you used to think of the North Pole, it's ice, you could walk on it, you know. It's so thick. But it's really not that thick, and it melts, and it can be gone. And so that channel change, if we completely lose that ice, then all the North Pole's Santa Claus stories are going to have to change. We're going to have to move Santa Claus somewhere else. We could put him on the South Pole. That has a lot thicker ice in Antarctica. Trey, pick your head up. The changing temperatures have caused massive changes in marine organisms. So now we're going to apply it to our marine biology. Species that do well in warm climates are thriving. Species that do well in cold climates are struggling. So this temperature change isn't bad for all creatures. Some creatures do well in warmer temperatures. And we see increases in those. Y'all don't need to write down every word, just summarize. Creatures in warm climates do better, creatures in cold climates struggle. Here we have 3 types of foraminiferans. Do you remember what foraminiferans are? Y'all remember studying these guys? Just pick, yeah, this one. Foraminiferans are like little shelled amoebas that float around in the ocean. We studied them when we were doing single-celled creatures. And they're real tiny. They got these little microscopic shells. And look what their numbers have done over the years. See the year, 600, 800, 1,000? How do they know how many of these things were around in the year 600? Can you guess? How do scientists know how many foraminiferans were around in the year 600?
Ice.
That was 1,500 years ago.
Core samples.
Core samples of what?
Ice.
Well, these things don't grow in the ice. In the what?
Fossils.
In mussels?
Fossils.
Oh, fossils! You're absolutely right. They go in the bottom of the ocean. They pull out the rock that makes up the very bottom of the ocean, where the organisms have died, and they have fossil remains, and they count the fossil remains. Number of cells per square centimeter per year. So 1 square centimeter is about that much. A little square centimeter is about that much of a square about that big of ocean bed. So they find a square centimeter of ocean bed and they count the number of fossils in it. And you can see the number on the side of the graph, 0.5, and there's only 0.5 fossils per square centimeter. But they can tabulate those numbers pretty easily. They count a whole square meter and then divide. And you can see all these guys have gone way up recently. Maybe this bottom one not as much as these other ones. Look how well this one's doing though. And historically, there wasn't much of it at all. But now there's a whole bunch because it's gotten warmer. If we change nothing about our lifestyles, CO2 emissions will triple in the next 100 years. Levels will become dangerously high. That means we'll be up to maybe 1,000 parts per million. Sea levels will rise due to melting glaciers and expansion of water due to heat. Storms, droughts, floods, disease, all expected to rise as temperatures rise. People don't think that global warming is, people think it's something that's far off. It's estimated that global warming already kills about 100,000 people a year. How could global warming kill someone right now? Can you think of a way?
Air quality.
Diseases. It is by diseases. How could global warming cause disease? You're right.
More bacteria will start growing, or more viruses will start fighting.
Okay, you're almost exactly right there. Have you ever heard of malaria? Malaria is the most common disease in the world. We don't have it in America, we're lucky. But tropical areas, India and Africa, it's everywhere. Especially areas near the equator, because malaria survives in a mosquito that only lives in hot places. As the planet's getting hotter, this malaria parasite is spreading because the mosquito that carries it is spreading to warmer locations. And so the mosquito that carries this malaria has spread. It's gone north in the northern hemisphere. It's gone south in the southern hemisphere. And so more people are getting malaria. So because of this global warming, you have about 100,000 deaths a year more than you used to have. Global warming is killing people right now. Yes?
Malaria apparently was found here in Glenn County. There was some
Really?
traces of it.
In what?
Traces of malaria and mosquitoes around.
In mosquitoes around here? Really?
Glenn County.
I know it's moved up into Mexico, and they're scared it's going to get into Texas. And it can be transported. These mosquitoes can come inside of, ships and stuff. Especially their little larvae are in water. So if you have a ship, and let's say you throw an old tire onto the ship, and there's some water inside the tire. You know how water will collect in an old tire. And then the ship takes the tire over here and unloads it. The malaria mosquito larvae will be in that water. And now you can jump from one country to another pretty easily. That mosquito won't survive if it's too cold. But if it's warm enough, it will. And so malaria could move into our country, and that would be a bad problem. So here's what is predicted to happen to our CO2 levels if we can continue going at the rate we're going. And these two lower lines here are what would happen if we significantly cut our emissions and stopped emitting so much CO2. So the question is, what do you do? How do you stop emitting so much CO2? Steffi, what would you do to stop emitting so much CO2? No idea? What's something that we do that emits CO2? Driving cars. Okay? So what could you do to lower your emissions of CO2 that come out of your vehicles?
Bike more often.
Okay, you can bike more often. Are you going to do that? Maybe not. Might be too far.
My light bulbs.
Yeah, you can change light bulbs to these compact fluorescent type light bulbs. Those don't use nearly as much power. You know what the big trend is going to be in the next 10 or 15 years as far as automobiles go?
Carpooling. Electric.
Probably not.
Smart cars.
Electric cars. I've got one. You know what electric cars run off of? Electricity. Now, electricity still burns fossil fuels. Most of the electricity we make in this country is from coal. Did you know that? That's how we get most of our power. And coal is a fossil fuel. And so most of the electric cars, even the one I have, I run off my car off electricity. It's still running off fossil fuels. But it's way more efficient because electricity created in a power plant can be created way more efficiently than than power created by burning gasoline in your car. It's about 10 times the efficiency. So it's way cheaper. I could charge my car and go 40 miles off of about 40 cents. If you go 40 miles in your car, how much are you spending?
All of my gas.
40.
Just kidding.
Do you know your efficiency of your cars? What's your miles per gallon, Trey, that you get in your truck? Do you know? You don't even
Mine's
know?
23.
23 miles per gallon? So you can go 46 miles in how many gallons of gas?
Like
23 miles a gallon.
Like 2.
2 gallons.
But it's different when I'm on the interstate.
2 gallons will get you 46 miles, right? How much does 2 gallons of gas cost?
$6. 7 maybe.
Maybe if it's $3.50 a gallon, is that what it's about now?
Yeah.
So $7. So you go 46 miles on $7. An electric car will get you 46 miles on about 50 cents. You see the difference? It's way more efficient. We're talking about 14 times the efficiency. If everybody drove an electric car, it'd be like only having 1/14 of the cars on the road. That's a serious improvement in efficiency. Moreover, if you don't make your electricity from coal, what's another way to make electricity without using fossil fuels? Do you know? Have you studied any of this before?
Wind.
Solar power.
Wind.
Solar power, geothermal, wind, but those aren't the main ways we do it because they're pretty hard. It's pretty hard to get a lot of electricity out of those, unless you have a huge waterfall. A huge waterfall like not Niagara Falls, the big dam they made over the river in Las Vegas. You know what I'm talking about? What's the name of that dam? Hoover Dam.
Hoover Dam.
Hoover Dam creates a waterfall that's so powerful that it can power the entire city of Las Vegas and a lot of its outlying areas, which is a huge city. So if you have something like that nearby, water power is great. The solar power and wind power, we're having trouble doing that. What's the one we use now that's not reliant on fossil fuels that we're using big amounts? There's one in Baxley, Georgia. It's not wood.
We'll start with
Starts with an N.
nuclear.
Nuclear power. Nuclear power can create electricity from nuclear material without using any fossil fuels.
Isn't that a lot more dangerous though?
Something like 15% of our energy comes from nuclear power in this country. And the more nuclear power we use, the less fossil fuels we use. Now, there is some danger in nuclear power plants because it produces nuclear waste. Have you ever heard of that stuff? It's pretty toxic stuff. But the thing about nuclear waste is you can confine it and you can put it somewhere. And it shouldn't hurt anybody if it stays confined. It'll be really nasty if we spill it and get it everywhere. But if you confine it, it should be fine. And it'll still be toxic for thousands of years. But right now, we spread our toxic pollutants into the air for everyone to breathe them and for them to change the temperature of our planet. Nuclear power is definitely the lesser of the two evils. At least you're not burning fossil fuels and you're not putting your pollutants into the air. You're confining them to a small area.
But eventually they'll all be let out. Maybe.
The plan is right now to build a big pit in a mountain in Colorado or somewhere and carry the waste to that pit and keep it.
What if you dropped it into space?
Well, lifting them into space is exorbitantly expensive.
Oh yeah.
then your nuclear power, if you charge your customers, if you took all your nuclear waste to space, suddenly nuclear power would be way more expensive than any other kind. So you want to do it cheaper. And that's the problem with solar power and wind power, is it's expensive. Because you got to set up a big windmill, or you got to set up all these solar panels. And by the time you get all that done, your solar power and wind power costs way more than the coal power. So nobody wants to do that because everybody's worried about money, right? So it would be, the cleanest thing would be to go to solar and wind power, but you'd be paying 20 times or 10 times your electricity bill is now. Instead of $100 a month, it'd be $1,000 a month. Would your folks go for that? Probably not. So they can't really do that right now. Nuclear power, though, is about the same cost as coal power is right now. It's a little bit more expensive, but not much. So that's a good alternative. These are things you need to think about in your lifetime. You have to vote on these kinds of situations. It's feared by scientists that positive feedback loop could develop from an increase in planet temperatures due to the reasons on page 237. There is a special reading section I want you to look at. Put a big star on page 237. These are problems that cause what we call positive feedback. Like we said with the ice, as the temperature warms, the ice melts, and it gets even hotter because the water absorbs the heat. And so that's a positive feedback loop. As the ice melts, it gets even hotter, it makes the ice melt even faster, and that just continues. There's a lot of things that cause positive feedback. They list them all here, and I want you to read about them. I'm not going to talk about each of them. You need to read this tonight. That there are several positive things that are driving the planet in the direction of more heat. And it makes temperature rise quickly in a logarithmic curve. Temperatures aren't just going to steadily increase, they're going to rise logarithmically because of these positive feedback loops. The same thing happened on Venus. Have you ever heard of the planet Venus? There's the planet Venus. It's hot there. Now the reason why it's so hot there is because of a greenhouse effect. Its atmosphere absorbs heat from the sun, heats up, and the planet has got so hot, the average temperature on Venus is like 790 degrees Celsius. If you take your oven at home, turn it on to its hottest setting, wait till it gets to broil, open it up and stick your head in that, Venus is about twice that temperature on the surface, and that's because of the greenhouse effect. And Venus was once like Earth. Venus once had oceans, but it got so hot that the oceans evaporated into the atmosphere and thickened the atmosphere with greenhouse gases. And that can happen on Earth if the temperature gets too hot. Now, it's not likely to happen on Earth because Earth is farther away from the sun than Venus. It happened on Venus because Venus is a lot closer to the sun, you see. And so it's getting a lot more heat. Luckily, we're further from the sun, so it's not likely that we get that runaway greenhouse effect like Venus had. But we don't want to be moving in that direction. And that's what we're doing as we raise temperatures. I want to skip this page of notes and just talk about ocean acidification. Here's another problem that having extra carbon dioxide in the atmosphere causes. I want to show you a chemical reaction here. Carbon dioxide, CO2, we're putting a lot of it into the atmosphere. Y'all got to hang with me to understand this. Carbon dioxide in the atmosphere reacts with water in the atmosphere to form HCO3. That's carbonic acid. This isn't a balanced equation, and there's other things that also form. But this acid falls into the oceans, rains down into the oceans. You know what we call rain that has a lot of acid in it? Acid rain. And it acidifies the oceans. Our oceans are becoming gradually more acidic because of this extra CO2 we're putting up there. Some of it, not all of it reacts with water, but some of it does and forms acid. The acid comes raining down. It's absorbed into the oceans. The oceans become more acidic. And it doesn't take much to screw up an ecosystem in the ocean. The ecosystem on the left is a coral reef, and on the right is what happens to a coral reef when it becomes too acidic. The coral reef becomes bleached. It's all white, you see? And that's because the corals are dead that are inside those coral skeletons. Remember, the corals made a little shell, and they live in their little shell, and they stick their little tentacles out to feed. Remember that? The corals have living with them algae, and the algae are colored, and that's what gives this reef its color. The colored algae that lives with the corals. But if the pH changes, it doesn't have to change much, we've found. It'll kill the algae, and the coral will die, and you'll just be left with the calcium carbonate skeletons, the shells of the coral, which are white. We're finding that this coral, it's called coral reef bleaching. Coral bleaching is the corals dying from too much acid. We find that that's happening all over the globe right now. And the corals are the bottom of the food chain in the ocean. So doesn't this seem like a problem? There's more bleached coral. So no wonder there aren't many fish nowadays. The corals are dying. The fish eat the corals, so the fish die. So now you just got not much stuff in your ocean. That's another problem.